Hi, my name is Erica Nash. I attend Clark Atlanta University. I am a sophomore biology major and I'm from Little Rock, Arkansas. I currently conduct research in the Center for Cancer Research here at my school. I'm also a member of Morehouse School of Medicine Undergraduate Health Sciences Academy, as well as I am on the Dean's List here at Clark Atlanta University. My career path has been greatly impacted by my research. I aspire to be a medical oncologist, and I have a passion for working with people, which is why I desire to go to medical school and have that experience with patients. Today I will be presenting to you my most recent research that I have done, which is how serum deprivation induces quiescence to manage oxidative stress in prostate cancer cells. Oxidative stress has been implicated in all aspects of cancer, from carcinogens to the tumor-bearing state. From treatment to prevention, oxidative stress can develop from many factors, including eccentric factors such as chemotherapy, drugs, radiation, UV, and intrinsic factors such as mitochondria. My grad students that I work with in my lab study how oxidative stress affects these cells. One of the effects of serum deprivation is an increase in reactive oxygen species, which causes oxidative stress in cells. So, an excess in reactive oxygen species such as hydrogen peroxide, superoxide radical, and hydroxyl radical, these can lead to damage in the DNA, and it can disrupt and lead to irreversible growth arrest, which is what we call quiescence. Now, if you look at figure 1 here, we have the cell cycle and the quiescence cycle. So we know that these cancer cells were regular cells at first, but have been mutated and can bypass cyclin-dependent kinases, which is why they are able to keep growing and eventually metastasize. Now we know that these cells are able to go into the quiescent state, which is where we call it a hiding state, which is where they're dormant. This we believe is causing people to relapse after they've been pronounced cancer-free. Now, these cells usually would perform apoptosis if they see an invasion or things like that, but instead of performing apoptosis, these cells are going into a dormant state, and they aren't growing, but they aren't dead. So we know that P27-KIP1, which is a cyclin-dependent kinase inhibitor, is what we would be using to locate these cells that are in the quiescence cycle, because we know that if these cells are still present but they are not proliferating through the cell cycle, that they are quiescent. And this is what we use in our study to find those cells. Now, my hypothesis was that serum deprivation can push prostate cell cancer cells to enter the quiescent state, thereby allowing them to manage oxidative stress. Now, my methods include cell culture, phase contrast microscopy, immunocytochemistry, and fluorescence microscopy. In figure 2, you can see how we used phase contrast microscopy to look at the morphology of these cells. And these serum star cells, which are right here, develop extensions which we can hypothesize that they are trying to move around or relocate. We also use immunocytochemistry and fluorescence microscopy, which is figures 3 and 4 here. We have our serum star cells, which we are focusing on here and here. Now, we use PC3 and DU145 prostate cancer cell lines. These cancer cell lines, we used this P20. We use P20. We stained P27-KIP1 with a red stain in order to see P27 present. We use the PMCA stain to stain the entire cell, and we use DAPI, which is this blue stain, to stain the nucleus. Now, as you can see in these TempStar cells right here and here, you can see there is greater accumulation of P27, which is what we hypothesized, versus these cells with serum, and H2O2, and it's just what we use to induce oxidative stress. And we concluded that the accumulation of P27 in the nucleus is indicative of the G0, G1 cell cycle arrest or quiescence. And we detected more accumulation of P27 KIP1 in the nucleus of PC3 and DU145 cells in samples that were starved and further exposed to H2O2. This supports the notion that quiescence provides adaptive protection for tumor cells under stress to ensure long-term survival. And for further direction, we would like to investigate if quiescence is essential for cancer cell survival, determine whether inhibition of P27 KIP1 allows cells to undergo apoptosis in response to oxidative stress, and explore the expression of other quiescence markers such as RB and MERK-DARK1B in response to oxidative stress. Thank you for listening to my presentation.